because we do want the Star Wars movie, not the Jim Cameron movie. I love Jim Cameron's movies, but you know what I mean. So. So we're going to launch on the fastest production ramp of any product, of any large complex manufactured product ever. And starting with building a 1 million unit production line in Fremont. That's line one. And then a 10 million unit per year production line here on the I don't know where we're going to put the 100 million unit production line. Maybe on Mars, I don't know. But I think it's going to literally get to 100 million a year, maybe even 1 billion a year. People often talk about like eliminating poverty, giving everyone amazing medical care. Well, there's actually only one way to do that, and that's with the Optimus robot. With humanoid robots, you can actually give everyone amazing medical care. In terms of Optimus will be more precise. Optimus will ultimately be better than the best human surgeon, with a level of precision that isn't possible, that is beyond human. So I think that's a pretty wild concept to say, okay, if people have always talked about eliminating poverty, but actually Optimus will actually eliminate poverty. Optimus will actually give people incredible medical care. So, so you start getting like sort of some pretty wild sci-fi sort of scenarios where, and some of these things I say will obviously be taken out of context and used in snippets and sent around, but whatever. I'm still going to say them. I think we may be able to give people a more, if somebody's committed crime, a more humane form of containment of future crime, which is if you say like you now get a free Optimus and it's just going to follow you around and stop you from doing crime. But other than that, you get to do anything. It's just going to stop you from committing crime. That's really it. Then you don't have to put people in like prisons and stuff. I think it's pretty wild to think of the various of all the possibilities, but I think it's clearly the future. My book recommendation for maybe the best, mostly utopian sci-fi future are the Ian Banks books, the culture books. So if you're curious, like what do I think the future is probably like? I think it's probably a bit like that, Asimov to some degree, but I think it's and Heinlein, Ian Banks, if you're like saying what does Elon think the future probably will be like for AI and robots, it's kind of Banksian. Now, and things do get kind of wild from an economic standpoint, because at a certain point with AI and robotics, you can actually increase the global economy by a factor of 10 or maybe 100. There's not like an obvious limit. Like Optimus is kind of like an infinite money glitch. And maybe there won't even be money in the future. Or money might be measured in terms of wattage, like how much power can you bring to bear from an electrical standpoint. I guess what I'm saying is hang on to your Tesla stock. Yeah. So, yeah, man, it's pretty wild. You're welcome. Let's see, I think we've got some slides to go through. I'm going to say ad-lib a lot of this stuff, but... So, when we started Tesla, the goal was to accelerate the advent of sustainable energy, and that's what we've done. I think Tesla has really led the way with electric vehicles, with battery packs, with a lot of solar, and many other companies have then followed our lead and done that. And electric cars, which used to be non-existent, are now prevalent. And the Model Y, for example, is the #1 selling car of any kind on Earth. But obviously now with AI and robotics, we need to update our mission. And our mission, I think it's good. It's a great mission, which is to achieve sustainable abundance. Which is, it's like, because I often ask people, like, what is the future that you want? What's the best future you can imagine? Because we want to try to make that future, like make the best future you can imagine. And I guess probably the best future is if people, can have whatever they want from a goods and services standpoint or medical standpoint, but at the same time we don't destroy nature, and we keep the rainforests and the beautiful national parks and all that stuff. And so that's what I mean by sustainable abundance. Is that people, can have whatever they want, have all their needs met, but we still keep all of the natural beauty that we want. Okay. I mean, if somebody can think of a better future, I'm all ears. But I think that's probably the best way to go. So yeah. Let's see. So. Yeah, as you know, every Tesla is designed to be autonomous. So it's sometimes difficult to explain to people if they've not. In fact, I'm sure you've all encountered this, where you try to tell people that the Tesla can drive itself, and they think you're crazy or something. I mean, especially like apart from the Cybertruck, our cars look pretty normal. I mean, they're good-looking cars, but they don't look super. They look normal. But I guess it's kind of like having a cat, or like, and the cat's just sitting. Let's say you've got a cat and it's like just sitting there on the couch, and you try to tell people that the cat can actually, it's actually Puss in Boots, and it can actually put on boots and a hat and swashbuckle and sing and dance, and people are like, no way, man, that's a cat. Until the cat does all those things. And you're like, damn, what the? We've got, millions of Tesla cars out there that are kind of like Puss in Boots. They're intelligent, but people don't know that they're intelligent. They look like normal cars, but actually they're super smart and can drive themselves. So I think that's probably the single biggest thing we need to do is to educate potential customers that you can either have a cat that's like a normal cat, or you can have Puss in Boots, and Puss in Boots is very cool. These days when people come to our stores, or even people that have the car haven't turned it on, we find, and sometimes people have paid for FSD and haven't turned it on. We're like, what? You should at least try it once. And so now the sales team. The service team will actually sit with customers and say, look, let us show you how it works and how easy it is. And then once they've tried it for even just a few days, they can't live without it. And now with version 14, we're actually getting to the point where we almost feel comfortable allowing people to text and drive, which is kind of the killer app. Because that's really what people want to do, and do. Actually, right now the versions, the car's a little strict about keeping your eyes on the road, but I'm confident that in the next month or two, we're going to look closely at the safety statistics, but we will allow you to text and drive, essentially. Yeah. So, yeah. It's certainly been the current situation, which often people will actually turn off FSD to text, then turn it back on, which is less safe. So yeah, that's probably the single biggest thing is just get people aware of FSD. And then obviously we need to get it approved in Europe. So we certainly appreciate the support of our customers in Europe pushing the regulators to approve FSD, because you can't even get even just normal supervised FSD is not allowed in Europe currently, which doesn't make any sense. And I've had these like crazy conversations with the regulators that seem like a Franz Kafka novel, where I'm like, well, look, we have billions of kilometers of data that shows that FSD increases safety. And they're like, well, we have to have all these committee meetings. I'm like, yeah, but people's lives are at stake here. So definitely a pressure from our customers in Europe to push the regulators to approve would be appreciated. And then we have partial approval in China, and we hopefully we'll have full approval in China around February or March or so. That's what they've told us. The fact that every Tesla car is capable of full self-driving, every car we build and have built for the last several years is capable of full self-driving is pretty wild, and most people don't know that. So, and then we've got the first car that is specifically built for unsupervised full self-driving to be a robotaxi. It's called a cybercab. It doesn't even have pedals or steering wheel. Yeah. So there's no side view mirrors. There's no So it's very much optimized for the lowest cost per mile in an autonomous mode. And that production is happening right here in this factory, and we'll be starting production in April next year. So the way that Cybercab is designed is it's designed obviously for a purely autonomous world, but also the manufacturing system is unlike any other car. The manufacturing system of the Cybercab it's closer to a high volume consumer electronics device than it is a car manufacturing line. So the net result is that I think we should be able to achieve, I think, ultimately less than a 10-second cycle time, basically a unit every 10 seconds. Maybe ultimately take a few years to get there, but it's theoretically possible to get to a 5-second production time. And so what that would mean is you could get on a line that would normally produce, say, 500,000 cars a year at a 1-minute cycle time, like Model Y, this would be maybe as much as 2 or 3 million. Maybe ultimately, it's theoretically possible to achieve a 5 million unit production line if you can get to the 5-second cycle time. So. It's a lot of cars. So these will be everywhere in the future. So, and we wanted to look futuristic, so it changes the look of the roads. So now the ingredients, when you look at what Optimus what's required to make Optimus and the various ingredients, what do you need to do high volume humanoid robot production? I think it's worth considering that really the cars we make are already robots, but they're four-wheeled robots. So Tesla is already the biggest robot manufacturer in the world because every car we make is a robot. And when you break it down to the fundamental elements, you've got batteries, power electronics, motors, gearboxes. You've got connectivity. You've got a vision-based AI. Hi, Optimus. And all the various pieces that you need for a humanoid robot. You need the AI chip. You need the AI software. You need to be able to manage a large fleet. And so really Optimus is a robot with arms and legs as opposed to a robot with wheels. So Tesla's ideally suited, I think, to succeed in this arena. You will see certainly many companies showing demonstration robots. There's really three things that are super difficult about robots. One is the engineering of the forearm and hand, because the human hand is an incredible thing, actually. It's super dexterous. So engineering the hand really well, the real-world AI, and then volume manufacturing. Those are generally the things that are missing. One or more of those things are missing from other companies. So Tesla is the only one that has all three of those. So this is the Optimus kind of initial. It's kind of the prototype production line. The high volume production line will be very automated, obviously, but this is really the production line that we use to make the prototypes. So you can get a sort of rough sense for what it takes to build the robot. Gotta pull the finger. And then, as I've said before, I think once we reach about 1 million units per year of sustained production or in excess of that, I think probably the cost of production is around $20,000 in current year dollars. So this will be certainly very affordable. Like I said, I think Optimus will ultimately increase the size of the economy probably by a factor of 10 or more. Next year we start production with Optimus version 3. What you're seeing here is Optimus version 2.5. Optimus 3 is an incredibly good design. The Tesla engineering team is amazing. When you see Optimus 3, it will seem as though that there's someone like a person in a robot outfit, which is how we started with Optimus. It really is going to be something special. And then Optimus 4, that hopefully starts production in 27, and then Optimus 5 in 28. So it's kind of like an annual release cycle with significant improvements with each one, and gigantic increases in the scale of production. So, yeah, sustainable abundance via AI and robotics. That's the future we're headed for. And as I think most people here know, the safety statistics show that miles driven on FSD are much safer than miles driven without it. So what this will translate to ultimately is saving the lives of millions of people and preventing hundreds of millions of accidents. So a massive increase in lives solved and tragedies avoided. It's going to be amazing. And how many people here have tried 14.1? Okay. All right, cool. Yeah, you can see even with the point releases, it's getting quite a bit better. It should be pretty smooth at this point. But really 14.2 is, there are major changes with 14.2 and then 14.3. I think by 14.3 is when we'll really be at the point where you can just pretty much fall asleep and wake up at your destination. So. And then I've been putting a lot of time into the new Tesla chip design because in order to have a functional robot, you have to have a great AI chip. And it needs to be an inexpensive chip, and it needs to be very power efficient. So we believe the AI5 chip will be probably about a third of the power of, say, something like a Blackwell, an NVIDIA Blackwell, which is a great chip, for roughly comparable performance, and much less than 10% of the cost. So. This is a chip that is very much optimized for the Tesla AI software stack. So it's not meant to be a general purpose chip. It's meant to be an amazing chip for the Tesla AI software. I mean, a couple things that I think how is Tesla able to achieve such an improvement? I think it is because we are specialized. We're not trying to. NVIDIA has to serve the superset of all past and future customers. So all of their requirements, all of the software that they've written has to work, which is a very difficult problem. Whereas we just need to make it work for our software. And so we're able to simplify the chip dramatically. And then we also, I think we're unique in this, but we have an integer-based system. And integer operations are fundamentally more efficient than floating point operations. So we can do floating point, but the vast majority of our inference is done in integer, which is, if you're familiar with sort of logic gates, like the simplicity of integer, and integer is much more power efficient, much more silicon efficient, but you actually have to train for integer inference, which everyone else is training for floating point. That's kind of like a niche technical detail, but it's actually very important. So yeah, this is going to be a great chip. So this chip will be made in basically in 4 places: TSMC Taiwan, Samsung Korea, TSMC Arizona, and TSMC Texas. And we already know what improvements to make for AI6. So I'm hopeful that we can, within less than a year of AI5 starting production, we can actually transition in the same fab to AI6 and double all of the performance metrics. So. I'm super hardcore on chips right now, as you may be able to tell. I have chips on the brain. I dream about chips, literally. I can draw the at least the broad brushstroke physical design of the AI5 chip by heart at this point. It's a good chip. It's a good chip, sir. So this is really key. Now, one of the things I'm trying to figure out is how do we make enough chips? I have a lot of respect for the Tesla partners, TSMC and Samsung. Maybe we'll do something with Intel. We haven't signed any deal, but it's probably worth having discussions with Intel. But even when we extrapolate the best case scenario for chip production from our suppliers, it's still not enough. So I think we may have to do a Tesla terafab. So it's like Giga, but way bigger. I can't see any other way to get to the volume of chips that we're looking for. So I think we're probably going to have to build a gigantic chip fab. Got to be done. So anyway, some of the stuff I've already talked about. We've done a tremendous amount for sustainable energy, and that's only going to grow over time. The world is moving towards a solar battery economy, which is ultimately that's where it was going to go anyway. But what Tesla's done is accelerate that outcome. Sometimes people don't understand quite how much energy comes from the sun. So the sun is 99.8% of all mass in the solar system, Jupiter being 0.1%, and then 0.1% is miscellaneous, Earth being in the miscellaneous category. So the total amount of energy, sometimes people say, well, we'll build fusion reactors on Earth. It's like, well, actually, the giant fusion reactor in the sky is basically impossible to beat, to such a degree that even if you could burn Jupiter in a thermonuclear reactor, the amount of energy produced by the sun would still round up to 100%. That's how much energy the sun produces. So solar power is necessarily the future. And I think there's going to be a lot of solar-powered AI satellites. And I think Tesla's going to play a role in that. We've obviously refreshed the product line, so S3XY. If people haven't tried the Model S, 3X or Y, or the Cybertruck, I recommend at least getting a test drive or a test ride, as the case may be. Try out the full self-driving, and I think you'll be blown away. So those who do not, if you might be listening and don't have a Tesla, you should try one. And of course, we've got the Cybertruck, which is the toughest truck of all time. It's literally bulletproof, faster than a Porsche 911, and can out-tow a Ford F-350. So it's a great car, great truck. And then starting next year, we manufacture the Tesla Semi. So this is already, we already have a lot of prototype Tesla Semis in operation. PepsiCo and other companies have been using the Tesla Semi for quite some time. But we will start volume production at our Northern Nevada factory in 2026. So we got two big products, or three massive products starting production next year. We've got Optimus, we've got Tesla Semi, and we've got the Cybercab. So, and then battery packs. So if you look at total U.S. power generation capability, it's roughly a terawatt. But the average power usage is less than half a terawatt. And that's because there are big differences in power usage between day and night. So the daily and seasonal variations in power consumption mean that the United States, and really every country, is only producing about half as much electrical energy as it could. Because without batteries, there's no effective way to buffer the energy. So what batteries actually enable is, even if you don't build any incremental power plants, you could double the energy output of the United States just with batteries. This is a super big deal. And in fact, I think that's really where most of the incremental energy production in the United States is going to come from. It's literally batteries. So a bigger deal than it may seem. And then we keep improving the battery design, so the Mega Block, which makes it really easy to deploy battery, utility scale batteries. So we've just simplified and brought more of the components to be internal to the batteries, so you can just show up and drop off a battery and it works. And then hopefully over time we will actually add more and more of the power electronics, so that Megapack will actually be able to output up to 35 kilovolts directly. So you won't need a substation, is what I'm saying. You can just literally drop it off, kind of like the way that a power wall, you just connect it to the house, the utility wires go on one side and the other side goes to the house mains, and that's it. So we want to get Megapack to the point where you just literally take the utility wires and you plug them in, and it just works. So. And then we've also built the world's largest supercharger network. So we do a lot of things here at Tesla. That's the biggest supercharger network in the world by far. And ultimately, you'll be able to go anywhere on Earth using a Tesla supercharger. And it's pretty close to anywhere on Earth, but it's going to be ultimately just anywhere. It'll just work anywhere. So the supercharger team has done great work expanding that and improving the efficiency of the supercharger network. And in North America, they did such a good job that the other car companies basically said, well, they'll just use the Tesla supercharger network. I'm like, okay, sounds good to us. You know, it's always important to have a slide on safety in the factory, so we continue to improve safety for our factory workers. We care a lot about their well-being. You know, like one way you can just tell like if a company is a good company or not, if you just walk through the factory or walk through the office and catch the vibe. And the vibe in the Tesla factory is good. People are happy. You know, that's how you know it's a good company. We've also put a lot of investment into raw materials. So we've built in South Texas and Corpus Christi the biggest lithium refinery outside of China, I believe. So it's starting off with 50 gigawatt hours of lithium, and we'll expand from there. So this is very, very important to have